Thank you so much, Violet, for that kind introduction. So I'm actually more of a scientist myself. So I'm part of IPCC Working Group 1. But then my day-to-day activities is mostly facing with the stakeholders, especially decision makers. But this afternoon, I thought I'd share with you more of a community and even personal perspective from the small islands in the Philippines, being myself a small islander and a part of some of the most vulnerable communities to climate change and specifically to sea level rise. All right, so I come from a small island called Bohol in the Philippines. So it's a proper tropical island paradise, the usual white sand beaches. But I think what's most unique about our island is that we also have a double barrier reef. And as you know, double barrier reefs are very rare geological formations. And this afternoon, I'd like to specifically zoom in the experiences of four very, very small islands off the coast of Tubigon, which is just on the southern tip of Danahon Bank, the name of our double barrier reef. So this is what one of the islands look like. This is an aerial shot. And just a little bit more about these islands. The first thing that you need to understand is that they are very low-lying with maximum elevations of just a little bit above 2 meters. And at the same time, they are impoverished. So they are, well, simple fishing villages that mainly earn their livelihood from fishing-based activities. So what happened in these small islands? So we actually had an earthquake back in 2013, which induced land subsidence in these islands. And as a result of that, there was an onset of tidal flooding, especially every spring tide. So today is actually, there's a super full moon today. And so the islands are basically flooded, I think, at this very moment. So in terms of the drivers of tidal flooding, we're looking at two. So locally, there's the earthquake in 2013, but then in the past 9 years, we have seen that the situation has become worse. And so we are also looking at global drivers, specifically accelerated sea level rise. So in this area, we are actually seeing sea level rise rates that are 3 or even 4 times faster than the global average. So this is just a survey that we did back in 2016. So in 2 out of the 4 islands, the flooding starts at 1.6 meter tides. In these islands, the highest high tide could reach up to 2.1 meters. So today is 2.1 meters. In these areas. So at 1.6, they already start experiencing flooding. And in the other 2 islands at 1.8 meters. And then the other 2 islands, it starts earlier at 1.6 meters. And they could be fully inundated depending on the tide level and also the local weather conditions. So with that, in 2016, we counted the number of days that, breached this threshold. And we counted 135 days, so that's like 30% of the year. What's more is that we, as I said, we experienced tidal flooding during spring tides, so new moon and full moon. There's also a difference in the timing of the flooding depending on the monsoon. So nowadays we have southwest monsoon, and so our flooding happens in the daytime. But then during the northeast monsoon, we have nighttime flooding. And nighttime flooding coincides with our local typhoon season. So these are just some images from the islands, but I also would like to invite everyone to check out our virtual reality setup for you at the poster hall if you haven't yet, because with that VR setup, we're actually going to walk you through what the island looks like during the actual flooding event. But if you've seen it, I hope that you are able to observe that the islands are, of course, very much affected by tidal flooding. But at the same time, life continues on these islands, and you see children playing and people still laughing and smiling. So it's a difficult situation, but this is their life as well. Okay, so the most important question, I guess, is what are they doing about it? I think in this conference, there's been a lot of talk about how expensive adaptation is, which is true, of course, but then does that mean that an impoverished fishing village like this one, is it already impossible for them to adapt? And so I'm very happy to report that it's not the case at all. So they have a range of adaptation strategies that they have implemented. And here I'm borrowing a photo from our friends from the Pacific Island who are basically protesting and saying that, we are not drowning and instead we are fighting. Okay, so these are the different adaptation strategies that are being implemented into Bigon. So they're classified into two. The retreat strategy, where you have permanent relocation as well as temporary evacuation. And you also have in situ strategies that are a combination of community-based adaptation, ecosystem-based adaptation, and coastal engineering. So I'm just going to highlight a few of them. So permanent relocation. So basically, this is kind of a knee-jerk reaction of the government. As soon as the earthquake happened and tidal flooding, started to happen, then they set up a relocation plan. But then almost 10 years on, none of the islanders have actually relocated to the mainland. And there are two obstacles to that. First is the funding. In the Philippines, at least, it's easier to unlock funding for rapid onset events, typhoons, earthquakes, but slow onset events like sea level rise and this chronic flooding, it's really hard to unlock funding for that. So there's no funding, but on the other hand, the islanders themselves are very reluctant to move, given that they are fishermen. And at the same time, they wanted to be very careful about their choice of relocation site, where they want to make sure that if they're moving to a place that's actually safer than the islands. But although the permanent relocation strategy is an existing option, we also have temporary evacuation, and this is the one that made a really big difference in the island. Like, it literally saves the lives of the islanders, especially during typhoons. So before the onset of tidal flooding, they only evacuated during very strong typhoons. But nowadays, anytime that there's a weather system coinciding with the peak tide, even if it's not yet a proper typhoon, just a tropical depression, then they already start evacuating either to the mainland or to the bigger houses on the island. So this has been very, very effective. And I guess the main challenge to implementing this on a bigger scale is that our early warning systems do not integrate tidal information. So the islanders have to manually look at the tidal calendar and also compare it with the warnings issued with respect to the timing of the landfall. So next is ecosystem-based adaptation. You have reefs and mangroves in these islands. But they have been, reefs especially have been limited in its, in its effectiveness, because the islanders do not really view the reefs as protecting them. They view the reefs more as a source of livelihood for the fishes. And so instead of protecting the reefs, they tend to mine the corals so that they could reclaim land, they could build seawalls, because as you saw from the photo earlier, there's not much trees, not much other building materials on the island. But on the opposite side, you have mangroves, and the communities appreciate very much the role of mangroves. They're above water. It's very easy for them to see how mangrove helps, dissipate the waves as well. So they have been planting mangroves everywhere that mangroves could grow. And then I think the last example here is coastal engineering. So coastal engineering is a bit like debatable in our context. The islanders really want to put up seawalls around the island, around the perimeter of the island. But at the same time, islands are living, breathing ecosystems, right? They tend to shift their shapes depending on the winds, the waves, etc. And so a lot of these seawalls are not properly designed, and they just end up like this, the one in this photo here, damage and end up just driving coastal erosion instead. So there's a lot of adaptation strategies going on, but I hope that you appreciate from my explanation that there's also a very real risk of maladaptation. So I borrowed this figure from Working Group 2, AR6, and then here there's a very tall order for successful adaptation. It says that for the adaptation to be successful, it needs to benefit people, it needs to benefit the environment, it needs to promote sustainable development for everyone, and at the same time, the strategy itself has to be transformative, and it also has to have mitigation co-benefits. So that's a lot. But in our experience, it's kind of tough to achieve all of these because there can be very real trade-offs. So the one example I gave earlier was the case of corals. There are no alternative materials on the island, so they tend to harvest those so they could elevate their land, reclaim land, but at the same time, they're also hurting the ecosystem. So there's a really delicate balance and trade-off that we have to face in order to avoid or minimize the risk of maladaptation. All right, so I'd like to spend the last few minutes of my presentation talking about loss and damage. So I think you remember I raised this question on day one, and this is because in our context, given all of the experiences we've had with frequent tidal flooding, we are really forced to think about what are the limits of adaptation. And this is especially how I personally felt like when in December of last year, so just a few months ago, we experienced a super typhoon that directly hit our islands. And what's worse is that we didn't have sufficient warning. So the typhoon rapidly intensified from category 1 to 5 in 24 hours, and none of the forecasts were able to capture this. So for example, UN OCHA has an anticipatory action program that was completely forecast-based. It ended up not being activated at all. So I guess that also asks us to, reevaluate the way that we rely on forecasts. Of course, as scientists, we love our science, but I think we also know firsthand the limits of science. And for example, one insight that I have from this experience is that we really can also integrate local knowledge in our early warning systems. For example, small islanders have very intimate knowledge of wind direction. So if that had been embedded, for example, in this forecast-based anticipatory action program, then probably it would have been activated, on time. So this is a photo of one of the island communities after the super typhoon in December 2021. You can see a lot of destruction here. And as a result of that, personally, I thought that they would, just relocate the next day. But then that didn't happen either. Instead, they started to still rebuild on the islands, but now they are more willing to relocate. But again, they are very keen about the process. It's really all about the process in terms of, site selection. Can they move with their neighbors, or it's, just everyone for themselves? So right now, the relocation program is gaining momentum, but still it's not an overnight process. Another limit that we are confronted with is hard limits, especially when it comes to coral reefs. Again, it was mentioned many, many times in this conference. I think Professor Stamer mentioned that 1.5 degree warming level is not likely anymore. And so we are really looking more at a 2 degree warming scenario, but that is really not acceptable for us anymore, because at that point we will lose all of our coral reefs, so we will lose all of the ecosystem services from our reefs, and we will also lose at the same time the protection that the reefs offer us. So these are the issues that we are thinking about. That's why we're thinking about loss and damage. So this is my final slide in terms of what climate action do we need. Again, I borrow this figure from Working Group 2 report. So they actually put forward a solutions framework. And this solutions framework has 4 areas: adaptation, mitigation, sustainable development for everyone, and ecosystem restoration. It's pretty comprehensive, but I would like to push forward, and my organization, Manila Observatory, is very much campaigning as well for adding one more component, which is loss and damage. So again, I know a lot of us here are working with adaptation pathways, adaptation options. I hope we consider what could be the limits of those so that we can start negotiating maybe even just the soft limits so that at least we can extend and avert loss and damage. So that's all. Thank you so much.
Thank you, Laurice. We have time for 1 or 2 questions. Yes, David.
Thank you. Lau, you mentioned the rapid onset of Super Typhoon Rai and how perhaps traditional ecological knowledge of the communities about wind wasn't really factored into early warning systems. Can you say more about how that could have worked, what could have worked, and your thoughts as a scientist on how to incorporate TEK with, hard atmospheric observation systems?
Yeah, I think the thing about at least the triggers mainly relying on the forecast is it means the triggers are very top down. So again, I'm trying to think about process-wise, is there someone in the table that's coming from the communities themselves? So in the decision-making part, the communities need to have a voice, and at the same time, even before, like the traditional knowledge can already be embedded. So if you recall, I mentioned that tidal information is not even included in our early warning. So the super typhoon hit us at 7:30 and our tide peaked at 9:30 p.m. We have tide calendars. We know we know all about the tides, and it's just very simple to be able to integrate that. But I guess it's not as important for others, unlike how important it would be for the islanders. So those are just 2 examples, I think, that they could be embedded. So process and also input from the start. Yeah.
Question from table 9.
Hi, thanks for your presentation. I'm really compelled by this idea of incorporating loss and damage. I don't fully understand how we would do that. I think I just need to learn more from you, maybe. But I guess I'm wondering, do you see that being included in adaptation pathways where you would find a threshold, a trigger that would say the damage is too great? Like if we see sea levels rising to this point or temperatures reaching this point, we know that there's this catastrophic loss. And so then we shift to more of like a planned migration pathway. Is that how you're seeing that being incorporated, or is there another way that you see thinking about that?
Actually, the thing about loss and damage right now is that there are 2 definitions. So the scientific definition is that it is simply the negative impacts of climate change. But then when you go to the policy level, and now actually the Conference of Parties this year is dubbed as the loss and damage year, because that's the focus of this year's COP gathering. They define loss and damage as pertaining to the adaptation itself. So I think that this is a case of the science catching up to the policy, which is similar to what happened with the Paris Agreement. So in Paris Agreement in 2015, they agreed at 1.5 aspiration, but the special report 1.5 didn't come out until 3 years later. So I really think it's about the science catching up to the policy, and hopefully the science giving a more nuanced understanding of loss and damage to align better with policy.